would like to introduce Adrian Perig, who will be presenting the SCION interdomain routing architecture. Adrian is a professor at ETH Zurich and has traveled here from Zurich, Switzerland to speak with us. This is Adrian's first time presenting at NANOG, and it's a pleasure to have him speaking with us today. Welcome, Adrian.
Thank you very much, Chris. It's my great pleasure to be here today and tell you about our 15-year-long journey in designing the SCION next generation internet architecture. It's a new internet architecture that can run side by side with today's internet, offering high levels of security, but also multipath. And I'll be telling you about this. And the good news is it's been in production for the last 7 years. So I hope many of you find it relevant. And I'm happy to talk to people who are operating IXPs or ISPs, or also writing end applications, and discuss with you how SCION can be relevant in your operations. So with that, let me dive right in. And looking at the future, there's one thing we can say that we can't really tell, of course, how the future looks like, but it's going to bear some surprises. And there may be new applications that will create new requirements for the internet, such as augmented reality or virtual reality or IoT and so on. We don't know exactly how they will shape internet traffic in the future, but definitely we can know that security will be important for applications and networks. Unfortunately, today's internet cannot provide very strong properties, and we see this, for instance, in this SLA from Azure that excludes any guarantees for traffic crossing the internet. There are a lot of great projects, security projects to increase security in the internet, but there was a challenge in deploying them because of also incentives and challenges to deploy new systems in general. And so with this, we also definitely experienced this in SCION to develop and deploy a new internet architecture. In fact, deploying a new system is so challenging. An analogy is to climb Mount Everest. And so you see some of the challenges we encountered, of course, are definitely to initially create the system, designing a new architecture, which took a couple of years, actually. This started throughout my career, always trying to come up with ways to secure the internet, but then finding that some inherent aspects of the internet challenge new designs. And so the dream to really create a new system that has fundamentally high levels of security was always in the mind. And so with this, then once you have a new architecture, you try with early deployments, but then very quickly you realize that finding customers or also additional deployers is very challenging because of a circular dependency in that entities who want to use a new architecture, they say, well, do ISPs deploy this? But then when you go to the ISPs, they say, do you have entities who want to use the system? And so this circular dependency makes any new adoption challenging. But even if you get through this, then a long-term deployment is very challenging, and of course a full deployment even more so. So the good news is we got quite far on this journey already, and I'll tell you about this in this presentation. So what is SCION? SCION is a new interdomain routing architecture, mainly developed for security, and security here means availability, not for end-to-end encryption. So you still need, of course, perform end-to-end encryption through a VPN, for instance, but SCION offers very high and very strong properties that you can actually communicate end-to-end, even if there's active adversaries trying to prevent you from communicating. So it's an interdomain multipath routing system and offering things like rapid failover through the multipathing that even if a path is not available, with high probability another path would be available, and so you can very rapidly switch over to that. And I'll show on the next slide, there's no state in the network, so this is a way to switch very quickly. So it's also a public internet. It's not a private network like some SD-WANs. So the idea really is to have public providers offering SCION connectivity in a federated environment. So SCION offers strong path control so that the endpoints can select paths that the network is offering and then know exactly how these packets will traverse the network. It's not source routing though, right? Source routing has two meanings. One is the path is in the packet, which is the case for SCION, but in SCION it's not source routing with respect to doing the actual routing. The network offers a set of paths, but the end host can only select among those offerings and not create its own path. So it doesn't have to know the network topology in detail specifically. So there's security built into all the aspects of SCION for discovering paths, but then also for using the paths. So there are cryptographic information protecting the paths so that entities cannot alter the information, and the policy by ISPs is being preserved. So the SCION use cases predominantly have been communications among an ecosystem of entities where setting up lease lines between each entity is simply too expensive. So the SCION network is offering something between the internet being a public network and lease lines. So where a SCION connection approximates the properties of having a lease line. So the structure of the SCION network is like today's internet. We have autonomous systems, but in SCION, the autonomous systems are being grouped into a construct we call an isolation domain. It doesn't mean it's isolating traffic, but it's really isolating trust, where essentially each isolation domain also sets up the local cryptographic keys that need to be trusted. So this is referred to as trust root configuration, TRC. And so there are no global keys that need to be trusted, right? So each of these isolation domain really sets up their own roots of trust that are then used to also create and issue certificates for all the autonomous systems. So each small circle on the slide represents an autonomous system. And at the top, you see what's referred to as the core ASs. These are the tier 1 ISPs or the larger ISPs that manage this isolation domain and provide the global connectivity. So this concept recently has gotten a lot of traction, actually, because you can also see, look at these ISDs like governance domains, where an entity can really create a governance structure and define the policies locally how these keys are being updated. The isolation domains can also be overlapping, so an autonomous system can be part of multiple isolation domains and get a lot of transparency about which entities need to be trusted for any given network operation. So here's the one-slide overview of how SCION works. I'll be happy to talk to you more about the technical details offline, but in terms of technical overview, that's unfortunately it for this slide. So here's how it works. We again see these isolation domains, 3 in this case, and the control plane creates path segments. And that's, in a way, you can look at this similar to BGP, but these path segments are then being registered at an infrastructure called a path server infrastructure. So it's a hierarchical mechanism, so there are path segments being found across core ASs, there are 2 segments shown in orange here. And so this operates pairwise in a way similar to BGP, if you wish. And then within an isolation domain, the core ASs issue what we call beacon messages. They're similar to, again, BGP updates that then find path segments inside an isolation domain. So thanks to this hierarchical structure, there is a huge scalability gain compared to BGP for finding these paths. So it's an extremely lightweight operation that's on the order of 200 times faster and requires roughly 200 times less work than BGP and roughly 1,000 times less work than BGP-SEC. So in essence, this path server infrastructure you can imagine similar to like a DNS system where end domains register the path segments under which they want to be reached. And when a source wants to send a packet to a destination, it contacts this path server infrastructure and requests path segments that the destination registered. It knows the path segments of its own autonomous system that it received, and then it also looks up the path segments combining the two. So in this example here, we have a host in F that wants to communicate with a host in ASS, and then finds the green path segments that S registered, its own blue path segments it has received, and then it looks up also these orange path segments to combine them, connect them. So in essence then, in this example, it has two combinations that provide an end-to-end path. And this path segments then, the end-to-end path goes into the packet header together with cryptographic information to enable each AES to validate the veracity of the information. There's also a control plane public key infrastructure that offers high availability that I won't be talking about more, but happy to talk to you offline. An important aspect of SCION is that it's stateless in the network. So routers don't need to keep any interdomain forwarding tables. The information is really in the packet header. And so a lot of aspects with respect to consistency or convergence are resolved this way, that the network is extremely stable. If the path, all the routers on the path are up, the path is always usable, even if the control plane should stop functioning, for instance. All right, I'm sure people will have a lot of questions on this. I'm, again, happy to talk to you about it. Let me now tell you a bit about the use cases of SCION. So for instance, you can do traffic management for your communication, and with the multipathing system, select and optimize each path for the properties that you need. For instance, latency or bandwidth. Or some entities want to do jurisdictional routing to make sure traffic stays within a jurisdiction, and so on and so forth. Another example is geo-fencing, where you can really ensure the traffic stays within a region. So here we see different routing segments or path segments. And an entity may want to stay within the dark blue and not use any of the light blue, and make sure this is actually followed by the network. In fact, SCION has inherent properties for path authorization, but also stronger properties to verify which path was taken. So in terms of path authorization, standard SCION offers the property that the end hosts know that each autonomous system on the path has authorized the use of this path. And this is done through digital signatures on the routing updates that are sent. So this is similar to BGP-sec. But then also the information in the packet contains message authentication codes that each AES can verify to make sure the path was and is correct and corresponds to a path that was being created. If you want a stronger property to really check that the packet truly went along the set of routers, there's a system called EPIC that is an extension of SCION that then gives the receiver this property to verify. So like all the aspects in SCION, it's stateless on the routers, and it's extremely fast. So this takes on the order of tens of nanoseconds in software, and it would take just a few nanoseconds if implemented in hardware to update this information in each packet, and then the receiver can check and make sure really the sequence of routers was correctly followed. And so there's some interesting use cases for doing so. If you want even stronger properties and check about the path inside an AS, there's an extension called Fabrit, which then also enables intra-AS properties. And for instance, segment routing can then be used within the AS in addition to SCION to make sure also the intradomain path is being used. But the way to specify these paths, find them, and so on, can be done through this system called Fabrit. Right, so you may be sitting there and thinking, this is pretty impossible to deploy. And like I alluded to earlier, there's this, and actually there's several circular dependencies between the entities wanting to use a system and the entities providing it. And there's additional circular dependencies, for instance, with standardization, because many entities don't want to use a system that's not standardized, and other entities and standardization entities don't want to standardize something that's not being used, and so on and so forth. And essentially, you need long-term incentives for everyone to participate, and that can be quite challenging, of course, to create. I'm sure all of you are well familiar with this. So the good news is that, in a way, we've made it to the first step to have the first set of ISPs selling and providing SCION offerings. And so the way this came about is by interacting with a financial ecosystem that had a use case where SCION was the perfect solution for them. So in essence, as I was mentioning, in 2009, we started with the research. And the first trials we had in 2016 with Swisscom and Switch, where we were allowed to place routers in their networks. And in 2017, the first customer came and said they want to use SCION in production. So not just as a POC or a test, they actually really took one of their sites off the internet and only connected with SCION in 2017. All the tests were very positive. And so a finance network was being announced, but the testing kept on going. And until the banks that wanted to use this technology also interacted with the ISP, and the first commercial products were then offered in 2021. So again, the way this came about is through a finance network that's called the Secure Swiss Finance Network, or SSFN, which essentially is the new Swiss interbank network. So they have a network today that's called Finance IPNet. And after 6 years of testing and work on this project, they decided to turn this off later this year. And this created a whole ecosystem of entities that then offered SCION services. So not only at the ISP level, but also consulting firms, software providers, and so on and so forth. A whole ecosystem has formed to provide SCION services to make this network a possibility. So there's this year over 300 banks that will get SCION connectivity. And so initially, of course, within Switzerland, and Switzerland being a very small country, this was feasible. But many of these banks also have international branches. There's also many international banks that are participating in this SSFN, doing trade in Switzerland. And so now we see also beyond Switzerland, Europe, and also in Asia, and of course, North America especially, many use cases where now SCION is becoming a requirement. So with this, an ecosystem has formed of companies, and all these providers work together to create this network, and which has been operational for several years. What facilitated this deployment is actually that it's not that difficult to deploy SCION. The biggest challenge is educating the operators and learning the new system. And since it's quite a new system and not as mature, of course, as today's internet, there's of course a bit more effort and work to integrate it with existing network monitoring and network operation systems. But from the hardware side, deploying SCION all it requires is deploying a few border routers, shown in orange here, connecting them to the border router of the neighboring ASs, and setting up what's called the control service. So the whole control plane runs on a separate server infrastructure. So the routers, in a way, are dumb switches. They don't even have forwarding tables, as I was mentioning. They only have a cryptographic key to verify network packets. And so the deployment is actually much simpler than when you think about deploying a new internet architecture. Internally, SCION reuses the local network, be it MPLS or an IP-based network, to facilitate communication among the border routers and among clients that speak SCION, and as well as the control service. So looking at the adoption after SSFN, there's a lot has happened then after 2021, with also the healthcare network being announced and actually being implemented last year. I'll be talking about this shortly. The SCION Association and also in the IETF, a lot of progress towards standardizing SCION and specifying it. In that time also what happened was that IXPs started offering SCION services, and in essence it's SCION can rely on a peering fabric like any like the regular internet as well, and so it's quite low effort for the IXP to offer such a SCION peering fabric. What's interesting is looking at exposing the redundancy inherent in an IXP and exposing this via SCION paths, so that the system, through the multipathing system, can then benefit from all the redundancy, use all the existing links in parallel, and switching over autonomously in case one should fail. So that's a next deployment model. But SwissIX has been running a SCION peering mesh for a while and is offering this. And there is research with DKIX and AMSIX and SIDN Labs to look at a SCION peering mesh like a SCION route server, how this would look like in this architecture. In terms of deployment, a big project was a healthcare project that happened last year. There's a healthcare provider called HIN in Switzerland, Health Infonet, and they were looking for a solution to protect. They have 50,000 doctors connecting to their servers, and they're looking for a solution to prevent routing attacks and also DDoS protection and so on to all these doctors. But many doctors' offices, all it is, it's essentially a home internet connection with a computer, hopefully not with Windows 95, but you can imagine the infrastructure is not very modern. And so it's a big challenge how to protect such a network. And thanks to a solution that the Swiss ISPs have rolled out called a gate infrastructure, there's a conversion of IP traffic into SCION directly at the ISP of these 50,000 doctors. And so this was done within a short amount of time to have the whole ecosystem move to this technology, and they're now using communicating through SCION with this HIN company. There's also a global education network that is being deployed, and the plan is to reach 1 million end hosts this year through this education network, and it's of course just part of the regular SCION internet. It's not a separate network, but in essence providing a bootstrapping of end clients that are in native SCION networks that can then, with SCION software, directly communicate using this network. Similar to healthcare, also the energy sector has looked at this technology, and they're now looking at creating an energy network that enables all the energy providers within Switzerland and then also within Europe to make use of this technology. The SCION Association was then founded in 2022 to standardize the protocol, work with the IETF, and also create a certification for software and hardware, and also for further developing the source code. So SCION is open source, and the SCION Association now has handling this open source system. as mentioned, SCION Association is also going to the IETF, is writing the drafts, and there's now a whole set of drafts that has been submitted as a specification to the entire base protocol. Not the extensions yet, but the base protocol is now fully submitted and available to look at. In terms of implementation, there are two main implementations. One is a commercial one by Anapaya, a startup to commercialize SCION, and the open source one by the SCION Association. The Anapaya one is written in C and Go, and the open source one is written in Go. And there's also under development APIs for many different programming languages like Java, Rust, Python, C, of course, C++, and so on and so forth. So the Anapaya commercial version also runs in the VM of many routers, router vendors. So for instance, especially on extreme networks, where you can actually get a router with support of SCION running in this way. Looking ahead, there are many open challenges. Of course, how do we evolve this protocol? There's a lot of discussions now in the IETF whether SCION should be an IPv6 extension header or if it should continue like a layer 3 header as it's currently implemented. Now, of course, for the local communication, there's again an IP header added, but this IP header is seen more as a layer 2 header to facilitate the local communication. One question also is how to and who would hand out the ISD numbers, SCION AS numbers. In fact, we believe that in SCION there will be 1 million plus autonomous systems, because as an autonomous system, you get the multipathing advantages and fine-grained path control. So we see even entities like in the cloud, like AWS recently announced support for SCION, where you can get SCION support at the VPC. And so the VPC actually would be its own AS, right? And this would obviously create, unfortunately, the AS space in SCION is quite a bit larger than in today's internet to accommodate for that. But the system scales because the end AS is not making any global announcements. The end AS only registers its paths, and so there's no broadcast from the destination. That's why the system scales to a very large number of autonomous systems. And the next question also is, how can SCION benefit end applications? For instance, like gaming applications or video conferencing applications that can make use of the multipathing to optimize for paths with low latency, or optimize for paths with high bandwidth or low jitter, or whatever is needed for the given application. So in conclusion, SCION is an interdomain multipath architecture that was started to provide high levels of security, but now also has a lot of other benefits that help with resilience and even performance. Today, it's being used to protect critical infrastructures in healthcare and also in the financial industry. And it gives us hope that actually it is possible to innovate in interdomain routing, right? So many people said for many years, Adrian, stop doing this, you'll never get anywhere. But it seems we were lucky. And thanks to this banking and finance use case, this has really driven the technology forward and has created a whole ecosystem of entities now supporting SCION. So of course, there's a lot of work left, and also hope in this community will also participate and look at SCION as a way to operate side by side with today's internet, so that it can be used, for instance, as a backup in case there's a problem with the internet. A SCION connection could be used instead with, and as the routing is independent, the faults and failures should also be independent. So if SCION doesn't work, it should not affect today's internet and vice versa. So that should offer a lot of exciting opportunities. So with that, here's some of the resources. The SCION Association, or also a SCION Lab, as an overlay testbed, so you can easily try this out. And also the open source code, the book, and so on and so forth. So with that, many thanks, and hope we have some time for questions. Right.
Hi, thank you for the presentation. I have a question from the online Q&A from Joe Schneiders. Is there anything that SCION cannot do? More specifically, are you aware of any shortcomings in the architecture or problems that SCION does not solve?
Right. So one challenge is the overhead in the packet header. Right. So it has about 80 additional bytes per packet. And when you have some of the extensions, path validation adds an additional 25 bytes to that. And so that's obviously a big disadvantage. And we try to address that, but yeah, that's definitely one of the shortcomings, that your good put diminishes due to that. In terms of security, we are ongoing formal verifications, trying to find if there's any problems. We actually did find problems in the past, and through a mathematical verification, not only of the protocol but also of the source code. And this is an ongoing effort that we hope to complete, to have an actual proof end-to-end that the whole system is secure, but that is not done yet. So I would say that's another shortcoming, that is not completed yet. But
Thank you.
Thank you.
Hi, Daryl Newcomb, independent. So I maybe you didn't cover, or maybe I missed it, the gateway function, but that's probably a long question. The one that's probably simpler is, either of the two activities, are they exploring DPDK or something that would accelerate a little bit on the host side?
Mm-hmm. Great question. Yeah, I didn't mention the way all these banks and doctors are actually using SCION today is through a gateway, right? So the gateway then translates from IP to SCION and back at the other side, so that you don't have to upgrade the end or update the end applications. In the long term, and through the APIs I was mentioning on the earlier slide, Rust API or Go or C, we hope that more and more applications are becoming natively SCION applications. And that's why also one of the goals of this rollout in educational networks, if we get to 1 million end hosts globally that would have native SCION support in their network, we hope that this will bootstrap application writers to start deploying this. You asked also about DPDK, and different systems. We have some systems that use AFXDP, and they can reach close to 100 gigabits with that technology, with kernel bypass. But more heavily, DPDK is being used to reach speeds of even 200 gigabits per second on a standard host, on a server without any special hardware support. So there's no FPGA or so, but with DPDK, much higher speeds can be achieved. And I've heard it's feasible to even get up to 800 gigabits per second. So we look at that and see if that can be reached, because SCION processing is extremely lightweight. And so we hope that we can reach these very high speeds on traditional servers. Does that answer? Okay, great, thank you.
Mm-hmm. Thanks. Warren Kumari, Google. Could you go back to slide 8?
8.
8 or 9?
Can people in the back help, or I can click? Yeah, I know I can click it a couple times.
Well, while you're doing that, a fair bit of the sort of advantage or sales advantage for this is sort of isolation domains, right? A lot of the power from SCION comes from isolation domains, and a sort of assumption that there'll be isolation domains at a geographic type level. It feels as though what you're doing here is you're creating tier 1 and tier 2 networks again, right? Like the top two IJ are a tier 1, and then you have two tier 2s of AB, KLM. And so if I'm hanging down the bottom, I need to ask permission largely to transit through my isolation domain to one in another country. And this doesn't necessarily seem like a good outcome, right? We moved away from that sort of thing. We moved away from country level type isolation domains because we thought the internet should be for everyone. And this feels like it's going backwards, but.
Great. Yeah, it's a very, very good question. So the first observation is that these isolation domains grow organically. So you can actually be part of a regular isolation domain like the country level, but also a global isolation domain at the same time. And you will get path segments from both. And as an application, you can then pick which ones you want to use for your end-to-end communication. But I think your question, and so what I'm saying is, the architecture does not prevent different models that actually look very similar to today's internet. But I think your question went also into censorship direction to say, to take the word isolation to also isolate traffic. And this is perhaps a mistake. We should have called the ISDs fault isolation domains or governance domains, because when you actually look at censorship, we believe it's more difficult to do censorship in SCION than in today's internet, or at least that the two are quite comparable. Because imagine if you're at one of these leaf nodes and you get a certain path, if the sensor does not control a given path that you see. So for instance, there's also a possibility for peering links that don't go up to the core. They're not drawn here, but they're possible. So if you see a path with one of these peering links that don't go through the core, you can use it in a way the core cannot deflect your traffic. Right? We've seen countries misusing BGP to also change traffic. And so this would not be possible in SCION, right? So if you're at a leaf node and you have a given path that doesn't go through the sensor, you have a guarantee that it cannot go through that sensor if the entities on the path don't, say, copy the traffic and send it elsewhere, right? So that's a fundamental property. But so what SCION offers is transparency, that for every path segment, you know exactly which keys you need to rely upon. And you can then also select which paths you want to use for communication, and that path cannot be changed. So there's several analyses actually of how SCION interacts with respect to censorship, and I'm happy to send those to you. And the outcome is that SCION doesn't make it any simpler to do censorship. You don't look convinced, so I'm happy to talk to you about it.
Do you want to?
I just have another question from online Q&A. No, please go ahead. No.
I mean, I'm not really convinced, largely because if I'm a network, there is a CA, which is likely to be run by the government in sort of the described model. And so if I'm in Turkey, for example, during the Arab Spring, it's easy for them to revoke my ability to be part of the network. They can be, this network has people who are not great or don't share my views. And so you can have, you even said it's part of the governance structure. There's a governance structure which runs or decides how the ISD works. And so it's relatively easy for the governance structure, also known as the government/telco, to decide who can participate and who can't. But I think this might be getting sort of off topic and down the...
I'm happy to chat because there's obviously a fundamental aspect. If the government controls all the egress points, right, the government controls that network. But if you're in Turkey and you get, say, access to another isolation domain, let's say through a satellite connection, then you can, of course, or maybe, I mean, satellite is obviously always feasible to get out of the country directly. But if you imagine getting access to another isolation domain that is not controlled by the government, if you can do that, then there's no way for the government to influence that traffic which then gives you a strong property, right? I'm happy to chat more. Right.
Sure. Now for our next online question. The question comes from Evan Moore. What influence did X25, if any, have on your research?
X25 is an older technology, obviously, that's been used. So we did look at a lot of ideas and that were out there, and SCION was influenced by many projects. The main influence came from a project called NERA. That was a project out of MIT that had some similar structures, and we tried to use all the best ideas, of course, from all these things. But from X25, I don't think too many things came. More so ATM, especially the quality of service extensions of SCION. Definitely, we looked at what ATM, the kind of properties ATM was offering for flow reservations, and that there's extensions I didn't talk about that then have some of these properties. Right? I should also say in a stateless fashion. So in SCION, the goal is that routers, or I should say, forwarding entities, like they're more like switches, are mostly stateless and don't have per flow state for providing these quality of service and so on, these different properties.
Thank you.
Thank you.